Hello everyone. Class 12th topic is boiling points in haloalkane. In previous video of boiling points in haloalkane, we have understood which factors are deciding boiling points of haloalkane. The two factors were there, DD interaction and van der Waals force of attraction. Now in this video, we will discuss some boiling point trends and we will try to find out the reason behind it. The first trend is CS3Cl, CS3CH2Cl and CS3CH2CH2Cl. The boiling point order is, its boiling point is 249 Kelvin, it is 3 285 Kelvin and it is 320 Kelvin. We will try to find out reason behind it. The reason is very obvious. From here to here, the size of particle is increasing. If I talk about CS3Cl, two CS3Cl particles will have less van der Waals force of attraction because size is small. And we know van der Waals force of attractions are decided by size. As we move toward this particle, number of carbon atoms are increased. So its molecule will have more van der Waals force of attraction. That's why to make them apart, we are providing more heat energy, which is represented through higher boiling point. And here, number of carbon atoms are further increased. So the molecule of this liquid will have very much strong van der Waals force of attraction as compared to previous cases. To break them, we require very high amount of heat energy, which is represented through this boiling temperature, 320 Kelvin. They require less heat energy as compared to these, and these particles will require least heat energy to become gas. Let's check next trend. Particles are hydrogens. You can understand by yourself. If I am not writing hydrogens, but hydrogens are there. This is the first particle, first haloalkane whose boiling point is 351.5. Second is, in this condition, the boiling point is 342 Kelvin. And third is the boiling point is 324 Kelvin. You can check number of carbon atoms are same. So number of hydrogen atoms will be same there. But from here to here, boiling point is decreasing. 351, 342, 324. Why? We can check what is the difference in them. It's a straight molecule and from first to third, branching is increasing. Branching is increasing. Branching means side chains. You can watch here, one carbon here is working as a branch and here two carbons are working as a branch. And it is a straight chain without branch. Now, why? Because it's a straight chain, its surface area is more. Due to larger surface area, it can make strong van der Waals force of attraction with its neighbor molecule. And these strong van der Waals force of attractions are creating higher boiling point for that. Now, as we will move toward this particle, surface area is decreased. Due to less surface area, the particles of this molecule will have less van der Waals force of attractions, which we can break by just providing little bit heat energy. Here we require very high amount of heat energy. That's why boiling point is very high. But to apart them, we require very less heat energy as compared to this. That's why boiling point is less. Reason, less surface area of the particles in contact. Due to less surface area, van der Waals force of attractions are less. And at last, when we check this particle, lot of branching is there. Almost the hydrocarbon part is spherical. Due to this spherical surface area, the van der Waals force of attractions existing between them is very less. Very less van der Waals force of attraction because surface area is very less in contact. So to break this force of attraction, very less heat energy is required, which is given by very less boiling point value, 324 Kelvin. So this is the reason, means we can make one relation. Boiling point is inversely proportional to branching. More branching, less boiling point. Less branching, more boiling point. Reason, with branching, the surface areas are decreasing, due to which van der Waals force of attraction existing between particles will decrease. Next trend, let's try to understand. CH3Cl, CH2Cl2, CHCl3 and CCl4. The boiling points are 249, 313, 334 and 350. Number of carbon atom is same, 1, 1, 1, 1. Chlorine atoms are increasing. As chlorine atoms will increase from left to right, size of molecules will increase. And we know if size is increasing, van der Waals force of attractions will increase. Means between CCl and CCl particles, there will be less van der Waals force of attraction because sizes are less, so we can break it very easily. The very less heat energy we can apart them, and that's why the boiling point is very less, 249. But if I moves to that, 2 chlorine atoms are there, due to which the size is increased, and increased size will increase van der Waals force of attractions. So here we will require high heat energy as compared to previous to make them apart and to turn them into gaseous form. That's why boiling point is 313. Similar trend is there. Now 3 chlorines we have, so boiling point is further increased due to increased size of the molecule. And increased size will have more van der Waals force of attractions between particles. And finally, CCl4, the boiling point is 350 Kelvin because of 4 chlorine atoms which are providing a very bigger size for the molecule, and bigger size molecule will have bigger van der Waals force of or strongest van der Waals force of attractions among all 4. So that's it. These are the trends we have in boiling point of haloalkanes. In next video, we will understand another physical properties of haloalkanes like solubility and stability. Thank you very much.